so you'll have that much already done. But that does not absolve you from your own All right, so we've talked about everything in the first 4 sections, but now we're going to try to bring it all back together. So problem number 1, this is pretest. Number 2, everybody's focused. Everybody's got a sheet of paper out. We're writing this down. Labeling it pretest number 2, so we know this one's going to be done eventually. So those of you that fail to turn in any assignments, at least you could turn in this one, right? If you're paying attention and copying down what I'm saying. All right, yes, pretest number 2. Here we go. First problem says simplify this guy. Now this is not even a trigonometric expression, it's just an algebra or an arithmetic expression. So we need to figure out how we're going to simplify it. Big issue is you got a fraction within a fraction. So take care of it however you want. The very easiest thing to do is just multiply everything by x. Everything by x. What's the purpose of that? It will cancel those out. And what do we have? 2x squared plus xy over 1 plus xy squared. Now, you're actually done. You might notice the top, you could factor an x out of the top, right? But would it do anything for you? The purpose of factoring would be to cancel. And if I take an x out, I'm not going to be able to cancel anything. So if you take it out, it's not wrong, but there would be no need to take it out in this problem because it isn't going to cancel. All right, got it?
Got it.
Easy. All right, so now we're going to prove a couple of identities. And this very first one, the very first one, is going to use the exact same idea we just practiced here. How are we going to start it? What'd you say, Keyshawn? Change the secant into 1 over cosine? I would. I would either change that into 1 over cosine or change this into 1 over secant. Either way, it's going to be the same amount of work, and I am weird about that. I feel so much more comfortable with cosine, even though I know it's going to be the same amount of work, but you could do it that way, absolutely, Tomas. And that would make sense to do it that way. Now, do you see how we have kind of what we had here? We have this little fraction buried inside the big fraction. So I'm going to multiply everything by cosine. Now, what's that leave me with? What do I have here? Cosine plus 1 over cosine squared plus cosine. Now, you remember over here, after we got that step done, we noticed we could factor the top, but I said, go ahead if you want to, but it's not going to get you anywhere. Look at this one. Can I factor the bottom? And what's going to happen when I do? I'm going to be able to cancel something out. So we always want to factor if it helps us. Now, what am I going to be left with then when I do that? 1 over cosine, which is secant. All right. Does that make sense to you? You all right with that, everybody? Right? You okay with that? I think so. Okay. All right, let's look at B. B is kind of scary. Now, let's just think about this for a second. First of all, my favorite thing to do is change into sines and cosines, but that's done. So I'm going to have to think of something else to do.
Can you split it in half and factor?
Can you split it in half and factor? What an awesome idea, but no, that's not allowed. Now, you could factor by grouping, but the problem is, well, I don't know. I don't think that's going to help me, and there's only 3 terms anyway. I don't think that would help me, but there might be something there, but I think we can do this a lot easier. Look at what you're trying to end up with. 1. So that means a whole bunch of stuff needs to cancel out. So what?
You have to switch everything, just like sine into cosine.
Switch everything to the same function, because what do we hope happens? When I do all this adding up, it all cancels out, right? There's 2 ways to cancel. You can cancel top and bottom. I don't have any fractions, so that's not going to work. Or I can cancel like terms. Sine squared plus negative sine squared, that kind of thing. So I'm going to make everything the same, and actually that's going to be easy to do, because what do we know about sine squared? It's 1 minus cosine squared. So this is 1 minus cosine squared plus 1 minus cosine squared times cosine squared plus cosine to the 4th. So like Chandler said, it's all the same now. And that was simple because we have that identity that changes sine squareds into cosine squareds. All right? So now this is a distribute right here. So we have 1 minus cosine squared plus, all right, here we go. What am I going to get when I distribute? Cosine squared minus cosine to the 4th plus cosine to the 4th. All right, now with any luck, we're going to lose everything except the 1. Do we? These are gone. These are gone. And all we have left is our 1. All right, now every problem is different. So you're not going to see this problem again. What skills are we taking away from this? What ideas are we taking away? Well, if we got to get a 1, we have to lose a whole bunch of stuff. One way to lose stuff is to add like terms that cancel each other out. So we decided to make them like terms, and that was easy because cosine or sine squared is 1 minus cosine squared. Okay. All right. Oh, speaking of squares, here we go. The next one. I don't know about you, but just writing it down makes me want to skip, because what do I see just as I was writing it down? Sine squared plus cosine squared, which is 1. That's 1. So I have 1 plus tangent squared. What's 1? I know. What's 1 plus tangent squared? Secant squared.
No way.
What did we want to end up with?
That is
Secant squared.
That's crazy.
That is crazy. Now, here's a scoop. What if you didn't know your identities?
I never know.
Then you wouldn't get it. So Mrs. Ford keeps saying, you gotta know them, you gotta know them, you gotta know them, and you do to be successful on these problems. All right, one more. Here we are.
Well, you can change you can change it.
All right, Chandler has recommended that maybe we change tan x into sine over cosine. Now remember, you do not have to have the whole proof planned in your head. You should just jump in and do something, because chances are when you make that first step, the next step will become clear, which it has. Now I have two fractions. What do I do when I have two fractions added together? I get a common denominator. Now I have no idea what's going to happen, but at least I'm getting points for doing something constructive. So here we go. What's my common denominator going to be? Cosine, 1 plus sine. So this one needs a 1 plus sine. And this one needs a cosine. So my common denominator is 1 plus sine times cosine. That's my denominator. What's in the numerator? Sine plus sine squared. So on top I have sine plus 1.
They're gonna cost out. Brain works.
And on the bottom I have a 1 plus sine times a cosine. These will cancel, leaving me with 1 over cosine, which is secant.
That is Lord.
Isn't that amazing?
Oh man.
Who knew?
Who knew words could be bad? I did.
You okay? All right.
No.
That part's done. Now we're going on to part 3. Now, part 3 is different. Notice the directions. It doesn't, John? Okay. You all right? Part 3 doesn't say prove, so we're not changing one side into the other. Part 3 says solve. So these are equations, and your answers are going to be something like x equals 60 degrees. You're going to get x equals an angle. You're going to get answers to the equation. So here's our first equation. Oh, and pay attention to the directions. The directions say you may use a calculator if you need one, and you are to solve between 0 and 2 pi, which means all the way around the circle. Now, notice the directions for B. This is A. What's different about the directions for B? It says 0 to 360. So what that is cluing me into is, when I'm doing this problem, I'm going to do it in radians. And when I do problem B, I'm going to do it in degrees. Now, doing the problem is going to be exactly the same. There's no difference in strategies. The only thing that's going to be different is, when it comes time to go to the calculator, I'll either be set in radian mode or degree mode, depending on the direction. So this one's radian. Alrighty? So here we go. Any ideas how I'm going to solve this equation? Do you notice anything about it? It factors. It's a quadratic equation. How does it factor?
4 and 1.
Tan x minus 4, tan x plus 1. Does that make sense to everybody?
Mm-hmm.
Which means tan x equals 4 and tan x equals negative 1. Now this is why you're allowed to use a calculator. Do you have a triangle that you have memorized that has sides of 1 and 4? No. So it's not a 30, 60, 90 or something. It is some other thing. Now, before I go to the calculator though, I do need you to tell me where these answers will be located. Remember, you're going all the way around. So could you have a tangent of positive 4 in quadrant 1?
Yeah.
Yes. Could you have a tangent of positive 4 anywhere else? 3. You could have a positive tangent in quadrant 1 or in quadrant 3, right? Because in quadrant 3, the 4 and the 1 would both be negative. Now, I need to know what that angle is. I have no idea what it is because these aren't root 3s and 2s and things. So I'm going to go to my calculator, set it in radians, because that's what these directions imply. We're setting it in radians. And what buttons am I going to press? Second tangent 4. And it tells me this is 1.33. I'm just rounding off to the nearest hundred. So instead of getting 60 like I do when I do it by hand, or 30 or 45 or something like that, I got 1.33 radians. 1.33 radians. Now the answers to the question are these angles. So it's this guy right here, which is 1.33, or this guy right here, which would be what? Be careful. You want to say 180 plus 1.33, but you can't. You have to say, you don't say 90, Griffin.
270 minus.
Oh, no, you don't say minus either.
270. 300. 300.
Oh my God.
181.
5 plus 1.33. Guys, if you are going to do 180 plus, since we're in radians, we don't do 180, we do pi. So if I add pi to that number, I get 4.47. So the two answers to the problem are 1.33 and 4.47. Now, those of you that are still confused, if I had put a 30-degree angle here, and I said, how big is that one? You would all say 210. And how did you get 210? 180 plus 30. In radians, we don't do 180s, we do pi's. So that's pi plus 1.33. We're not done. Yep, we're not done. If that was your question, we aren't done. Why are we not done? We haven't done the second half of the problem. Remember when we factored, we got two values for the tangent? All right, so tell me where this one is. That one's going to be in quadrants 2 and 4. Right? Now that one you actually could do by hand, but since I allowed you a calculator, we'll go ahead and do it on the calculator. You need to know what this angle is right here. You need to know what it is. So I'm going to go to my calculator, and what buttons do I press? Second tangent 1. And it's 0.79. I never put the negative in because I've already accounted for the negative by putting it in the quadrants I put it. If you put in the negative on a cosine problem, it really screws things up. So I don't normally put it in. I know it's negative because I put it in quadrant 2 and 4. I just need to know how big that angle is. And I got 0.79. Did you? So what are the answers then? The answers, the diagonal lines are the angles. This is your angle. So this is your answer. How are you going to find it? Pi minus 0.79. And while I'm here, how am I going to get the other one? 2 pi minus 0.79. And again, if you are all confused, stop and think about how you do it in degrees. If you had a 30-degree angle right here, you would all tell me that's 150 because you did 180 minus the angle. If you had a 30 here, you'd all tell me that was 330 because you did 360 minus the angle. We're doing exactly the same thing. We're just doing it with pi's. All right, so second pi minus that. I got 2.36 for this one. And I got 5.5 5-0 for this one, does that sound about right? All right, we okay?
Fantastic.
All right, let's do the next one. Or at least get it started. The next one is going to be in degrees. How do you know it's in degrees, Mrs. Ford? I look at the directions, which is always a good idea. 0 to 360. Now, this one says cosine 2x equals sine x. And I'm going to tell you, this one we're going to do with no calculator. This one you do not need a calculator on, so we're not going to use a calculator on this one. Okay? Man, this one's got some complication. What do you think, Tomas? You could absolutely do that except for one complication. This is a 2x, and this is an x. So that's like having two different variables. You can't combine them at all. You would certainly, if that were an x, that would be exactly how I do the problem. I would divide and get a tangent. But you can't with the 2x. That 2x is really problematic. Is there anything we can do with the cosine 2x? Let's look at the back of our green sheet.
Ooh, I know.
What do we know about the cosine of 2x?
Well, there's 3.
Equals 1 minus.
So it equals three different things, right? Or there's three versions of it, right? Now, which one, you get to pick, you get to choose, any of them will eventually work. But which one would make the most sense given that you already have this in the problem?
1 minus 2 sine squared.
1 minus 2 sine squared. So if we choose 1 minus 2 sine squared as a replacement for cosine 2x, this is where we would be, right? So this is a straight substitution. Cosine 2x is 1 minus 2 sine squared. Now take a look at that equation. What kind of equation is that? That is a quadratic equation. And when I solve quadratic equations, I like to have them set equal to 0. So I'm going to take everything over here and I'm going to shove it over there. Alright? So 0 is going to equal what? I'm moving everything over. 2 sine squared plus sine minus 1. Now, somebody remind me and we'll pick up here tomorrow. But guess what we're going to do with that guy? Factor it. And then we're going to proceed just like we did here. So, I will see you tomorrow. If you're bringing in material, I need it by 3:05. Get it down here if you're bringing it in.
I weigh 90 pounds before day of school. I'm about 105.
Thank you.